Hey everyone, today our group will be presenting a project titled Automatic Ceiling Fan. This is not just about an ordinary fan but an innovative solution. Our fan is designed to automatically adjust its speed according to the room temperature, providing maximum comfort with better energy efficient. This project is collaborative by our team, which consists of Nunila binti Sabini, Muhammad Hazim Aiman bin Yusuf, Muhammad Afiq Hazik bin Muhammad Taufik, Siti Nuraipah binti Jumatsah, and me, Wan Shukri bin Abdullah.
The background of our project are focusing on the growing impact of global warming on everyday life, especially here at UNIMAS. Over the recent years, the university has experienced noticeable increases in temperature, affecting the comfort and productivity of students and staff. Recognizing this challenge, UNIMAS took proactive measures to enhance the campus environment. One of the key initiatives was the installation of ceiling fans, especially in heavily frequented areas such as the student pavilion and various campus cafes. These fans not only help to reduce the heat, but also create a more inviting and comfortable space for students to gather, study, and relax. By promoting natural cooling, we aim to improve the overall atmosphere and support student well-being. This is just one of the many ways UNIMAS is working to create a better, more sustainable future for its community. The primary issue we face is that the current ceiling fans at UNIMAS are inefficient. Despite providing some relief, these fans still use a traditional design, which brings several challenges. If this problem is not addressed, the continued use of these outdated fans could lead to higher energy consumption and increased operational costs. On top of that, these traditional fans often experience damage within the first year of operation, adding to maintenance expenses. Our goal as a group is to innovate and improve the current ceiling fan system. We are focusing on designing a new fan model that enhances functionality in multiple ways. This upgraded design will provide better airflow, reduce dust accumulation, and significantly improve energy efficiency. By implementing these improvements, we aim to create a more sustainable and cost-effective solution for UNIMAS.
Effect analysis change. For the chip material, we'll go to 4 fans design and blade condition. And even blade is called to blade condition and poor maintenance. For the constant high-speed operation, we go to poor maintenance and efficient motor. For fans design and blade condition, we go to efficient airflow. Blade will go to dust accumulation. Poor maintenance and efficient motor will go to not energy efficient. These three will conduct to the UNIMAS efficient ceiling fans, which is efficient airflow, dust accumulation, and not energy efficient. This is a cause and effect analysis chance for UNIMAS efficient ceiling fans.
So I will be presenting about function analysis. In function analysis, we have subject, function, object, and function evaluation. Firstly, we have a remote, which is to control the fan, and the function evaluation for remote is insufficient function. Secondly, we have a blade, which is to produce wind, and the function evaluation for blade is insufficient function. Thirdly, we have the LDC motor, which is to spin the fan, and it is an useful function. Fifthly, we have net filter to remove dust, and the function evaluation is an useful function. Next, we have digital temperature sensor to adjust fan temperature, and the function evaluation for digital temperature sensor is useful function. Last but not least, we have AI voice recognition, which is to control the fan, and And the function evaluation for AI voice recognition is an useful function. Next, we have interaction analysis, where we have people and a remote van. So, the people use a remote van, and the remote van travels the people. After that, we have this analysis where a fan produces wind, and the wind produces airflow, and then the airflow evaporate sweets, and then the sweets remove the body heat.
This is the shoe feel. The problem statement is that the traditional fans with blades requires manual remote control, which is the time consuming. Substance and feel. Substance 1 is the temperature air, substance 2 is fans, and last is the field air force used to move the air and controlled by the remote. Existing system, first for substance is temperature air, substance S2 is fans, 3 is field force is manually applied via the remote control to adjust the fan's speed and direction. Harmful function, field fatigue to take a remote. In the queue function, time consuming manual control. Modify system for the automated field is replace manual remote control with automatic regulation based on environmental temperature. The improvement is new field. F1 is automatic control system temperature based. New substance field interaction is automatic adjustment based on room temperature. The conclusion is an automatic control system creates automatic speed fans, enhancing air movement efficiency. This modernized traditional fans, improving functionality and user experience. This is the figure 7 for the problem. When the user feels hot, it will go to manual remote, and the manual remote will connect to the fans, which is F2. So fans will go to the user. This is the traditional for the problem statement. This is the figure 8 for modify. When the user feels hot at the environment temperature, the system of the fan or the auto remote will detect the temperature environment for the user. When the high temperature, the remote will automatically adjust their surf and go to fan. Fan will cooling down the user when user feel hot based on the temperature environment. This is a trimming for ceiling fans. Rule B. Ceiling fan hold fans and person hold remote control and in front of fan, but actually people don't need to control the fan. The fan automatically change speed depending on temperature. This is a trimming for the ceiling fans. The before diagram, the before figure 9 and 9, which is manually traditional fans. This is we use a manual control through the number 0 until 5. After figure the next figure 10 is after, which is a modify. We use a fan disk, air filter, digital temperature sensor, which can detect the temperature environment of the room. AI voice regulation mode, BLDC motor. AI voice regulation mode is more when the user feel hot. The user can directly talk to the fan and make inform to sure the user feel can adjust their speed. This is a diagram for the future modify fans.
Engineering contradiction. In our project, we identified an engineering contradiction related to the automatic ceiling fan system. If manual or remote control is removed from the ceiling fan system, then it will increase the overall productivity of the system as the fan speed will automatically adjust based on the room temperature. But this will increase the complexity of the design as additional technology like sensor and automated control are required. To resolve this contradiction, we apply three inventive principles. First, principle 12, equipotentiality, replacing open blade design with a disc-based structure to enhance safety and efficiency. Principle 28, replace mechanical system with field, utilizing a BLDC motor that operates on electromagnetic principle instead of conventional mechanical motor. Number 3, principle 24, mediator, incorporating a digital temperature sensor and AI voice recognition for more efficient and user-friendly control. This engineering contradiction approach not only address the identified contradiction but also significantly improve the overall functionality and design of our system. Thank you.
This is the function-oriented search, or well known as FOS. In the table 1, you can see some of the key disadvantages. Firstly, we have a remote control. Some of the remote controls might have many buttons and functions which can be confusing for those who are not tech savvy. Next, we have an old BLDC motor that can produce noise pollution. Then we have lead that can pose a safety risk, especially household with children and low ceiling. Other than that, dust accumulation that can trigger allergies issues, especially people with asthma. Lastly, take up space because of the big size of the blades.
Secondly, as shown in Table 2, is possible technologies. These technologies include a disc as an alternative to an open blade, where it is noted for its modern design, higher safety and energy efficiency. Next, the LDC motor is known for its high performance, efficiency, durability, and low noise compared to the regular AC motors, employing an AI speech recognition module that provides convenience and a futuristic approach where we can use our voice to control the fan. Next, a digital temperature sensor that doesn't need to be manually adjusted as compared to the outdated ceiling fans. Last but not least, a net SNL filter, which is noted for minimizing dust accumulation, and this is a feature that the regular ceiling fans are lacking. In a variety of systems and devices, these technologies hold great promise for enhancing user experience, safety, and efficiency.
So now, I would like to explain a little bit about the S-curve for the ceiling fan. So, as you can see from below, from the first one, the first ceiling fan is quite traditional for its design, and it uses a control panel on the wall. After that, it got evolution on the second generation, which is the fan is more look fancy on the controller, and the fan design is become more look expensive. And the third one, we can see the evolution. The fan design is more complex and more fancy from before, and the controller is much simpler, which is using a remote on hand. But now, as you can see, the latest one that we are making is the ceiling fan. The design is more simpler than before, but the control efficiency is much better than before. For sure, the control efficiency is we don't have to click any button to control the fan, and we just can use our voice to control the fan.
Okay, with that, I conclude my presentation. Thank you for your time and attention. If there are any questions or feedback, I'll be happy to address them. Have a great day. Sorong papan, tarik papan, bye-bye channel Alif Ifan. Mantap.